Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS and Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will look at stormwater and wastewater PFAS regulations and how industry is responding. With that, I'd like to introduce our presenters for today. We are pleased to have with us today John Cuthbertson, Associate Vice President and North America Industrial PFAS Lead for AECOM. John Cuthbertson has over 30 years of environmental consulting experience supporting oil and gas, chemical, and industrial clients. His primary focus during the past 7 years has been PFAS, and during this time he has supported hundreds of projects across North America involving various PFAS issues. He has worked seamlessly with clients, management, and legal executives to develop internal PFAS programs, policies, and strategies, has led and directed clients' national PFAS programs, and has assisted with addressing risk management issues. We're also pleased to have with us today Scott Wilson, President and CEO of REGENESIS. Scott Wilson has extensive experience in the development and application of advanced technologies for groundwater and soil restoration. He is a widely published expert with over 30 years experience designing, installing, and operating a broad range of remediation technologies. He has expertise in project management and has directed the successful completion of large industrial remediation programs under state and federal regulatory frameworks. At REGENESIS, on specific projects, he plays an active role in technical oversight and program management to ensure conformance with customer expectations. All right, so that concludes our introduction. Now I will hand things over to John Cuthbertson to get us started.
Well, thank you very much, and I'm honored to be speaking today. Not sure how I end up on a distinguished speaker panel, but I'm glad to do that. And if anybody knows me, I love to talk about PFAS. I pretty much eat and live this daily. And today we're going to focus on a topic that I've talked about a little bit in the past, but not much. It's been developing quite a bit, and that's stormwater and wastewater regulations and how that's coming to be across the country. Obviously, it's not consistent, and more importantly, you know, how are facilities and industry struggling to respond to these new changes. So, for an overview today, I want to definitely go into some of the regulatory trends, and again, a lot of this will be, you know, my take on these trends. And what I'm seeing working with a multitude of clients and in a multitude of states. I want to also focus on, you know, how these states are driving these regulations. So we know they're out there and they're coming, but how in practicum are they being delivered in forcing our clients to have to respond to when dealing with that? And so I'll have some case studies. Obviously, my case studies are fairly limited sometimes, just due to confidentiality. It seems that not many people want their facility associated with PFAS. So let's jump right in, and I'm going to start off kind of at a bigger picture on the federal level with the EPA. And the EPA has become more active. You know, their action plan was out a few years ago. It kind of got off to a slow start, and it seems to, especially with the new administration, things are moving along at a much more rapid pace now. And about a year ago almost, the EPA came out with this NIPIDs interim strategy. I'm sure many of you had seen this. And so this was a document that they were discussing internally as they're looking forward with how to handle primarily affluent streams through NIPIDs permits, whether that's a stormwater or potentially a wastewater. And in there, the recommendations that had come out of this were really for wastewater discharges were a lot of best management practices, which also could include treatment. And then on the stormwater side as well, they were looking at, how do they control stormwater and treat it if necessary. So more recently, which was released just a couple of weeks ago now, were the preliminary affluent guidelines, this program plan 15 by EPA. And on the right here, you can find this in the federal registers if you just Google for it. And so basically what they're looking at is they're looking at, limiting the effluent and providing these guidelines here. And if you go through this, it talks about, what may be required for monitoring and best management practices and even pre-treatment standards for wastewater. It also goes through some of the industries that they're keying in on with this and where their focus is for this. And then also there are categories too, like for metal finishing, that they're also having a category to address that as well. And, I always like to try to figure out where things come from and what happens. And something that kind of went a little bit under the radar was this document that came out by EPA. And this is really like the background resource to this program plan 15. And this document is actually a pretty interesting document. If you're interested, you can Google this. And I just pulled out one of these tables here. And so it really kind of goes through this document goes through and talks about who they're focusing on and why, and specifically what aspects of, the manufacturing processes they're concerned about PFAS being in. I mean, a lot of this we knew before, but a lot of this is based upon a whole series of studies that have been done in all these different areas. So really, this is all just to say is this is a backdrop. And, on a federal level, this is being looked at, and this probably will be rolling out. And my guess is in not the too distant future where we're going to have a lot more uniform regulations on NIPIDs with our effluents, especially the surface waters. So when we're dealing, so the federal government is the federal government, and things have, they've kind of really not been driving PFAS issues as much, and I really find that that's being driven a lot more on a state level. And the difficulty we have with that is all of these states are doing different things, and some of them have been very aggressive to PFAS. Some of them are just becoming aware of it, and some of them aren't really dealing with it, whether that's because they don't think they need to based upon, manufacturing in their states, or they just haven't been pushed to yet. So here's a figure on here showing the United States, and there's a whole bunch of colors, and hope it doesn't weird people out. But I really tried to break this down a little bit to show, where, so the gray ones these are states where really they're not doing much of anything yet for PFAS. And again, I'm not talking about, this is all really more towards the environmental side. I'm not talking about products or foams or anything like that, because some states are very active in the product side, but they're not as active in the, in the environmental side. The green ones are states where they're getting close. They're drafting regulations. They're coming out with, recommendations that are in various forms of review or stakeholder comment periods. And the dark blue ones are states where there is some sort of a PFAS regulation. In some states, it may be drinking water. Some it may be just an environmental. It could be a biosolids. It's very varied. So all these states don't have the same types of PFAS media that they're developing criteria for. And then the light blue ones are some ones where, they're kind of regulating it, but they're really defaulting to EPA lifetime health advisory that they had come out with several years ago. On the bottom here, I did put in here too, these are MCLs. These are states that actually have MCLs for drinking water, and I have listed on here just PFOA and PFOS. Some of these states are well beyond this. And I did highlight yellow for Pennsylvania, just because they're one of the latest ones now that are entering in, and they have proposed MCLs for both PFOA and PFOS as well. So this doesn't really help us a lot because many of my clients don't exist within one state. And a lot of these states are trying to push regulations that maybe they don't have any justification for yet. There's a whole host of things, and it's being handled very differently. So it makes it very difficult for companies to address this because they don't have a set scale of objectives. It can change state by state depending on where their facilities are located. So a lot of what I want to talk about today is really going to come into this, again, this is what people care about most is so how are these states driving these regulations and how is this coming about? So I kind of, for reference, I put on the right-hand side the DEFCON scale here. And there's three areas that I'm going to talk to today and really focus most deeply on number 2 and number 3. But, we all know that many states are now approaching PFAS by facility types. There's been a lot of information out there over the years about different types of facilities and their association with PFAS chemicals and their manufacturing processes. And that's been well documented. I'm sure everybody on the call knows that. So that's one that's been out there. It's a concern. It's definitely something that can have a regulatory driver behind it. But I really think, more concerning has been the stormwater effluent and attention now given to NIPIDs permits and such. That has a lot of problems for us. There's a lot of challenges, both in assessing that, but then how do you rectify that as well? And then the one I think is the one that's, the DEFCON 1 here, which, is quote unquote war ready. This is stuff we're definitely dealing with on a day in and day out basis in many states where there are requirements now that we have to meet for an effluent. And that is definitely challenging in a wastewater, which I'll get to. Okay, so let's talk a little bit about these facility types. I'm not going to spend a lot of time here. It's pretty straightforward. So again, as I mentioned, and I just put up a handful of them on here, but there are definitely different industry types that have been targeted through research and through documentation of what they've done, what's in their waste products already, and what's been used. And probably none of these surprise anybody on the call. So many states are developing lists of these different facilities within their states by these different industry types. And when, if they have the authority to, they often are asking for some sort of sampling to be done at these facilities or evaluation. So a couple examples of this is, in California, they kind of entered the PFAS theme a little bit late, but they definitely came at it with a robust charge. And they kind of rolled out this phased approach. And, a couple of years ago, they had this phase 1 come out where and this was all driven by municipal sampling that was done throughout the state. And I should mention that, that is something that we need to be very cognizant of. When we see states starting to do statewide sampling events of municipalities or drinking water or whatever it may be, surface waters, once they get that data, then they're like, okay, we have to figure out what the source of this may be and how do we get this under control to protect human health and the environment. So California came at this in this phased approach. And first they came and hit airports and landfills. They got completely inundated and overwhelmed with the response that they got from that. And it took them a while to staff up and figure out how to attack that. It was quite a while later, at least a good year, and then all of a sudden they had another order come out for chrome plating facilities, and I believe there were over 350 of them that were part of that order. And again, they had to go out and assess their facilities for past PFAS usage. Generally in the chrome plating industry, that was well known for being a mist-suppressant to control vapors from their employees. It also has historical roots in that industry as well. It definitely had beneficial properties to the surfactants in the application of the chrome to the materials that they were plating. And then after that kind of came out of nowhere in my mind. I didn't hear much about it. Then they put one out to all the wastewater treatment plants, and this one's more concerning to me. And again, this will be our third topic today. I think this is just another drive for them to determine additional potential sources. And then what was supposed to come out almost 2 years ago finally came out earlier this year, was for the oil and gas terminals and refineries. And there were about 160 some odd facilities that were identified, and actually the work plans for those, they were required to put work plans together to look at, soil, groundwater, stormwater, and wastewater at their facilities, and look at where their PFAS usage was and develop a sampling plan to determine if there were issues in any of those streams. Another one that's kind of interesting too, and this kind of gets more towards permitting and nippities. Colorado came out last year and had these questionnaires for permittees, and on the right here you get to see a partial list of some of the different types of facilities, and again, ones we've heard of and seen before, but it was really a massive fact gathering operation that they did to really get this information. And we saw New Jersey just did this year too, where to many of their industrial facilities throughout the state, manufacturing facilities, they put out questionnaires about PFAS, and that one was extremely extensive. I helped many clients navigate through that as well. So this is all just to say that this is becoming an ongoing issue, potentially for how sites can get identified. And here's a case study I'll use at how this can become, how this can come about as well. So here is a former tannery that I was heavily involved in for quite a while. And what's interestingly enough is where the star is on the map over here, that's where the facility is. And what happened was there was a lot of discussion about the textile industry, and there were some grassroots groups of people that were getting together and talking about this in this community. And they had heard about there was a potential area where waste from the tannery was disposed, on a farmer's field in the back. And they kept putting a lot of pressure on the state agencies about it. And hey, we think you should sample our wells. And finally, after getting the attention of the media and such, everyone acquiesced, and they began sampling residential wells. And that was over in this area here. And you can see then that, this is a heat map, and, red is above criteria. You can see that once they started sampling these residential wells here, the plume was migrating kind of off to the right of the page here, that this was a much larger issue than they had thought. And this led to evaluating everywhere they may have potentially disposed their material. I think over 110 locations were evaluated. And on here, you can see these colored dots all over the place. And these are all separate areas where these materials were disposed. So this is how these things can come to be. And once they do, they sometimes can take a life of their own. I know on this project, there were over 2,600 residential samples collected throughout these areas here. Okay, so now I'm going to get more into the heart of what I want to talk about today a little bit, and talk about this stormwater effluent and wastewater effluent. But first, let's hit stormwater. So we've been seeing this trend, or I've been seeing this trend, where states are very concerned about their surface water bodies, and there's two primary reasons. In many states, surface water can be used for a drinking water source. So there's definitely concern there. And, when they do treat water, for drinking water, that typically does not include any process that will take care of PFAS. So that's definitely one driving concern they have. And then the other is the accumulation of PFAS into biota, and especially PFOS. One of the driving C8 PFAS isomers that are of concern, they tend to bioaccumulate in fish. And as we all know, many states, fishing is pretty avid and people eat these fish. And so it's another completed pathway. So that's been their concern about these surface waters. And then how do we protect these surface waters? So when we're dealing with stormwater, and this is pretty straightforward, but the primary issue we have is we're mostly concerned with superficial releases. So anytime there's a process or waste from a process that gets onto a ground surface, that has a chance to come in contact with rainwater. And once rainwater passes over that, we find that those chemicals very quickly, dissolve and transport into the stormwater, and then can end up in our stormwater collection systems at a site. Probably one of the larger culprits that we've been dealing with a lot, at least I have so far, has been aqueous form filling foam at either airports or chemical manufacturing industries, oil and gas, a lot of those types of facilities there. So that's definitely a huge issue that we have. Is so we really have to start accounting for every drop of water that hits a facility. Does it have chance to come in contact with this and get into our stormwater? And so on many facilities that we have, stormwater can be left unchecked. It doesn't always go back to a wastewater treatment plant. Many times surface water is just, directed and diverted, and it discharges to a surface water body. And obviously, that's where, the state regulatory agencies are really wanting to reduce that down as we keep seeing PFAS concentrations increase in surface water. And I know in New Jersey and in Michigan that the agencies there specifically have been requesting for PFAS to be added to NPDES permits on renewals. They don't have a rule that says from now on everybody's doing this, but as the new permit renewal process comes along, they've been doing this. I know other states have hinted at that as well. And I mentioned California before with their orders. I've noticed that some of the more recent orders are focusing a lot more. They have a very large stormwater component to it, where they do want that evaluated and that stormwater sampled as part of an initial, just a preliminary evaluation. They want the stormwater sampled even prior to you recognizing that you do or do not have a release of any PFAS raw materials at your facility. So be that as it may, and however this ends up into our stormwater, this is presenting a lot of challenges. I kind of joke sometimes, it doesn't seem like anything with PFAS is easy. And, we're learning new things every day. But when you're addressing this impacted stormwater, what options do you have? So options that I've seen and we've implemented at facilities is we've taken, if we do have impacted stormwater, sometimes we've been able to divert that to a wastewater treatment plant on site. Well, that's just directing it somewhere else. And then we have to put some kind of a mitigation in place for that. But sometimes that's a little more of a controlled environment where we can do mitigation if necessary. But that's something that's been done. I think one of the huge things for addressing stormwater is minimization efforts. And so, basically, again, we know we have impacted, sediments within a culvert, or we have impacted soils or surfaces where rainwater is running over and picking up that PFAS concentration out of that and putting it into the stormwater culverts. And so over on the right here, I've seen this be a lot of as lining parts of sites. So if we find a site and we know that PFAS materials were either used or disposed at certain parts of facilities, or there were leaks or releases to surface, maybe our best line of effort here, like in the far right, might be the line areas. We do this sometimes around, volatile tanks. If there was some kind of a release and either AFFF was used for a vapor suppression, or if there was a fire, this is a way where we can at least stop the rainwater from having contact with these impacted soils. And again, that's going to minimize the stormwater, the concentrations in the water going to stormwater. Just to the left of that a little bit too, is this also works within drainage features on facilities. So oftentimes you may have a release area, this stormwater gets into these drainage features. Well, the next thing you know, we have a whole bunch of impacted sediment within the drain feature as well. So we may remove that sediment, or sometimes we may just line the ditch, with some type of a barrier. And there's lots of different products. There's aquablock, there's different kinds of coring materials. There's all kinds of things we could use to make some kind of a permeable barrier. This is also effective when we think groundwater venting to a stormwater may be an issue. So if we do have some shallow or perched water that is venting to a drainage feature as such that's getting into our stormwater, and the groundwater is the source of the PFAS, we can also line these, these drainage features or line culverts or whatever it may be to reduce that contribution. And our treatment options when we're dealing with impacted stormwater are still pretty limited. I've been involved in a couple of projects now where we're trying passive treatment, via, some sort of a barrier within there. And, on the right here, you can see, here's a diagram of like an aquagate rembind material used in combination, where we're running stormwater through that on a passive mode to have that reduced concentrations prior to an outfall discharge. Another option we've been doing, if it is a groundwater issue, I do have sites where, some pretty large sites where we've actually used Plume stop, and we've injected that in the subsurface to create a barrier, as you can see kind of on the diagram on the far right there, to drainage features, to stop, to basically reduce concentration in impacted groundwater prior to it venting, to the drain. This requires a lot of research and experience though, because you got to be very careful that you just don't, you get the plume stop to stop and park where you want it to. You don't want all your drainage swales and surface water starting to turn black. And then the last thing we have, which is kind of like we have with everything else, is pulling stormwater out of these culverts and running it through carbon, or fill in the blank, some sort of absorptive or separation technology to remove the PFAS out and then discharging it. Again, none of these are phenomenal answers, but there are ways in which we can do this. But again, this has only been something that I'm aware of that's been being dealt with in the last year and a half or 2 years from a stormwater standpoint. So one quick case study I have is the Selfridge Air National Guard base where we work, and we had notice of violations due to an outfall having elevated PFAS concentrations in a stormwater outfall. Those concentrations could be as high as north of 10 parts per billion for PFOS. That's typically one of the driving constituents in PFAS that we have. And so we had to really look at this and do some modeling and figure out where is this material coming from that's getting into the stormwater, and where is that migrating, and what's that fate and transport look like, to figure out what we could do to potentially address that. And so at this particular facility, we are basically removing the water from the stormwater drains themselves, the culverts, and then running them through separation media. And we've been using, and on here actually, we're still in a piloting phase on this, where we're removing it using, we're trying a couple different carbons and a fluorosorb as well, to try to see what type of removal we get with all these, what's more beneficial, you know, what's more cost effective down there. But through all this too, you know, we need to be minimizing and understanding where the contributions are coming from at the facility, because if we cannot treat the end-all tailpipe, that's going to be better. We'd rather treat farther upstream and retreat lower volumes rather than having to have something that can handle much higher volumes. And so the study here, you know, identified that, you know, most of the contribution of PFAS was from 4 individual catch basins. So they're kind of being dealt with individually to try to do that and to take care of that. So it's a very interesting project. The results have been very strong. You know, there'll probably be more documentation coming out on this in the near future. So let's switch over to the last topic here, which is wastewater effluent. So I'm not going to say Michigan is the state that really drove all of this, but Michigan's the state that, you know, the state I think that really came up with a very effective plan, you know, to identify where PFAS is getting into wastewater treatment plants. And obviously the driver is, so this is how it goes. The state has had a surface water quality number. They've had it for, I think, over a decade for PFOS and PFOA, and the PFOS concentration was 11 or 12 parts per trillion, depending on if you were, you know, 11 if it's a drinking water source and 12 if it wasn't. And that was the discharge criteria. So Michigan then went to the wastewater treatment plants and basically told the plants and said, listen, your discharge from your plants has to meet this. So we are requesting or requiring you under statute to sample your influent and effluent. And basically, if your effluent exceeds, you know, we're requiring you to sample your industrial influence coming from industry to determine if you can find out where this PFAS is coming from. And that worked out well, you know, from the state standpoint, because it did identify hundreds of facilities in the state of Michigan, you know, where PFAS was being discharged to the wastewater treatment plants. And then, you know, then the responsibility is on the wastewater treatment plant, you know, and they have a whole bunch of their own regulatory drivers of their own of allowing or not allowing waste to be discharged to their facility. So again, that led to a lot of issues for industry to how to quickly address their effluent. And I have a case study that I can talk about that in just a moment. So here's a state that had a regulatory driver for it. So many states really started to try to develop and model a program similar to what Michigan did, and Wisconsin was one of them. And a while back now, Wisconsin tried to model this, and they put out basically what was a request. They just requested the wastewater treatment plants to sample their influent and effluent. Wisconsin does not have a regulatory driver yet. They're working towards that. You know, their regulatory process for developing new criteria is very onerous. It takes a while. It'll probably be within a year, you know, sometime early next summer is I think when that promulgation process will come to an end, and they'll be able to actually have the driver. But through all that, you can see that basically everybody declined, except 2 wastewater treatment plants that were already dealing with it due to industry discharges that they were already aware of. And again, I mentioned earlier the California wastewater sampling. You know, they're requiring this without, there's not necessarily a regulatory driver for it yet, because, you know, data's being collected and nobody really knows in California what we're comparing it to at the moment, be that as it may. But again, you know, you can see this huge list of who they want you to target if you have issues, you know, in your water, and they're already teeing this up for all these wastewater treatment plants there. So that's definitely, you know, problematic. You know, for industry of not knowing when you may be, you know, when this may just become your problem. So how do we address these issues, within our wastewater? And again, I think there's a lot of keys that need to happen with that. There's a lot of challenges. First is, we really need to identify what the contributing sources are in the facility. Do we know what parts, and some facilities are quite large, do we know which parts of the facility have PFAS or had PFAS or had, historical PFAS that's just impacted equipment that's still discharging? Can we isolate that and understand where that is within the facility? And then if we do, are there minimization efforts? Are there things we could do to stop that PFAS from being discharged, to this stream? Sometimes that may be difficult. And part of that minimization efforts too, maybe be looking at alternative products or materials that could be used in your process that don't have PFAS, or at least don't have, the PFAS that have been found to have environmental concerns. There's also the cleaning of equipment. So we run into this a lot where, once PFAS, especially a raw material, hits your equipment, like let's just say, for example, like in chrome plating, in those acid baths there, where this was sprayed on top of, it's virtually almost impossible to remove PFAS from that equipment itself. And many facilities are faced with either treating an effluent coming out of their facility or replacing all of their equipment. These surfactants tend to bind into things, whether it's metal or concrete. This could also be for your wastewater treatment plant piping or your wastewater piping at your facility, that these can become impregnated with that too. And then we're also dealing with the variations in our effluent. So some facilities where the PFAS is coming from, that water stream may not be constant. It might run once a week. It might run certain hours of a day. We often find that it's hard to evaluate wastewater just because the concentrations vary so much. And oftentimes we get into auto sampling or different things like that to try to find averages or means in which those concentrations exist. And so some of the things we're often left to do as part of this minimization is evaluating, what does the piping system look like? What condition is it in? Is it cracked? Is groundwater venting into any of this? As you can see on the bottom right there, there's a photograph of, infrared camera work looking at, you can see where that crack is in the concrete. You can see that lighter yellow area. Well, that's groundwater infiltrating into a culvert underneath that's directing wastewater. Sometimes we can do coating of materials or coating of processes to stop that as part of a minimization. But ultimately, if we get down to where we have to do a treatment of a wastewater, we are still limited to some sort of a separation technology, whether that's a carbon or an ion resin, or some type of filtration, nanofiltration, different things like that. Those all can potentially work reverse osmosis. Other challenges that we have for the wastewater is we're dealing with a lot of co-contaminants. So we often run into needing to do pre-treatment. Sometimes to treat PFAS, it has to be a pretty clean water stream. So we may need to knock nettles out, or if there's other hydrocarbons or volatiles in there, or any other material that would compete for carbon or resin space, we need to make sure that we're pre-treating those out. Sometimes it's pH. It could be a lot of different things. And we all know these wastewater streams can vary depending upon the facility. And the problem is too is, again, we have these very low thresholds that once water leaves a facility in which we're allowed to have there. So I have a case study on this. And I've used this for a little while. It's just a good small case study to talk about. We had been working at this former chrome plating facility for a number of years. And we had a groundwater extraction system there that was basically pumping out groundwater, leaving this former facility, and sending that water to the wastewater treatment plant for treatment of chromium and nickel primarily. And the wastewater treatment plant, they get it, they knock out all the metals, and everything's good, and we have a capture protecting these down gradient residents. Well, this was in a state where they did require that the wastewater treatment plant effluent meet the state's criteria. They didn't, so then they sampled their influent streams, and sure enough, this influent there from the groundwater extraction system where we were knocking the metals out had 8,000 parts per trillion PFAS during that sampling. So that basically led to a cease and desist letter from the wastewater treatment plant, basically giving them a time frame. You know, basically you have 45 days to rectify this, or you can no longer discharge. And so we had to move very quickly, you know, to put in we put in a GAC system with, you know, it had some resin in there to knock out metals as the pre-treatment in it. We ran a sacrificial carbon on the front end, regenerated carbon, and then we went to, you know, full carbon for polishing on the back end. And we had to build that and have it in place within 30 days. So we were able to rectify that. You know, we can do this. I mean, it's been running for over 2 years now with our effluent at less than 2 parts per trillion. But then this leads to a whole host of other issues where we had downgrading residential wells with elevated concentrations we were dealing with. We're doing this off-site investigation. We got discharged to surface water bodies. And then just to make fun, right next to the facility, we have a dairy farm. So they had water going to cattle. We had a bunch of irrigation wells. So, you know, once PFAS comes to you, you kind of lose control of it. And these are some of the issues that we're stuck with. So, well, I could share a lot more today, and I hope you found this helpful and everybody took away something interesting. At this point, I'm going to hand it over to Scott Wilson.
Well, thank you very much, John. It was really good to have that overview of current regulations. And because of the shifting sands of regulations across our nation with regard to PFAS, it's particularly difficult for all of us in the industry to follow. So I really appreciate it. I'd like to shift gears now a little bit and talk to you about, we're going to focus on groundwater treatment, and this will be very brief. I just wanted to give you an update on a new program that we're launching here at REGENESIS. And with regard to groundwater treatment for PFAS, we really took some time to poll site owners and responsible parties that have PFAS issues in groundwater and ask them, you know, what really is the ultimate solution that they're looking for? I mean, we can't magically make this go away, and it's only going to become more regulated. So what would be the ultimate solution? And you know, there were several attributes of that solution that really jumped out at us. One was that they wanted it a finite cost because of the long-term, you know, prospect of you know, year after year treating and pumping in groundwater. They'd like to see a finite cost. They'd like to see a guarantee of performance. They'd like to see low financial risk going in. And so we heard all that, and we've developed a program we call Plume Shield. And I'm going to introduce this to you today and speak a little bit about the aspects that I think are worth pursuing here. So just as an introduction to Plume Shield here, we have a proven track record now treating PFAS in the subsurface for groundwater. We have we actually performed 18 project sites, and of those 18, 17 of them have been exceptionally successful. I mean, beyond our imagination in terms of meeting regulatory criteria in a very short period of time. The one site that didn't perform well, we're working on it. It appears that it's actually a landfill site, downgrading of a landfill, and we think that the total organic carbon mass that's coming off the landfill was ill-defined. So we're going back and looking at that. But we feel very secure in the way that our plume stop is working in the subsurface to treat these sites to the point where we're willing to guarantee performance. And in trying to meet the attributes that the market's calling for, we're going to offer warranties. And while we're going to do a standard warranty of 10 years, we can move that up to 30 years if a site owner or a responsible party or an engineering firm working for those responsible parties requires. The other thing that's very unique about this is we'll be implementing it with no financial risk to the end user or to the site owner or engineering firm. There's no money that exchanges hands until the goals are met in key monitoring wells. So let me go through a little bit more detail here and give you some background. So what is Plume Shield? It's actually an advanced PFAS remediation system that eliminates the environmental risk of PFAS in groundwater, and we use our Plume Stop product. And if you're not familiar with Plume Stop, John mentioned it in his talk, it's actually a colloidal activated carbon, and what we do is we take coconut fiber carbon, mill it down to the size of a red blood cell, suspend it with food grade polymers, and it makes a black ink that doesn't settle out. Looks just like black water. And you can pour it right down into monitoring, or not to monitoring wells, you can pour it right down into wells and injection wells, and it'll spread out in the aquifer and actually coat the aquifer permanently with a layer of highly sorptive activated carbon. The result is it permanently converts a contaminated aquifer into a purifying filter. And the way this looks is in this diagram here, we have the PFAS, this is an airport, for example, and let's say there's a fire training pit to the right of the screen, and you have PFAS in a permeable zone moving through the subsurface from the right to the left. You come in with a geoprobe or monitor or injection wells, and you apply the Plume Stop into the flux zone, that is the zone that's taking the contamination, and it converts that portion of the aquifer into a purifying filter. As the water moves from right to left, the PFAS contaminants are stripped out permanently onto the carbon. And clean water comes off on the left, where you can see the monitoring well showing clean carbon. And just to give you an example here, this is, on the left you see cores, that's one hole, and that's the actual cores out of one hole. And you see the black is where the Plume Stop was actually placed in the flux zone, and the soil below is not coated with the Plume Stop because it wasn't injected there in that zone, nor was it injected above in the top. We've actually targeted this very well right into the flux zone. So now you're stripping all the PFAS out, and down gradient to the left, you've eliminated any risk of contamination. So from a plan view, what's it look like? Here you see this Plume Shield, which is the actual holes in a line, very closely spaced, with a robust injection of the Plume Stop colloidal activated carbon directly into the aquifer, treating this plume of PFAS emanating from the other side of the street. So you're protecting the wells to the left of the barrier. We call it a barrier, but it's actually just a permeable barrier, a filter zone. And all of the PFAS is being stripped out, and you have clean water impacting those wells. So you're protecting the homes to the left with their domestic water supplies. So one of the questions that comes up is, are you really performing remediation since you're not just throwing the PFAS? Instead, the PFAS is simply sorbing onto the Plume Stop in the subsurface. Well, remember that risk is equal to hazard times exposure. And by putting the Plume Stop in the subsurface, it rapidly sorbs the PFAS. And by doing that, you eliminate the exposure because it's no longer moving. And by eliminating the potential for exposure to down gradient, you are in fact eliminating the risk. And by eliminating the risk and cutting off the path and route of exposure, you are successfully remediating the site. And that meets the criteria for the definition of remediation per the ITRC, the Interstate Technology Regulatory Council, if you're familiar with the regulatory group that is really on the leading edge of policy for PFAS. So where have we actually treated PFAS with Plume Stop and this type of technology? We've actually completed, as I mentioned, 18 successful project sites so far. There's several others going in right now, but there's in the design and review phase, there's 120 some other projects around the world that are moving through the process and will be installed in the coming years. What types of projects? Everything from airports to Department of Defense sites to bulk storage facilities and refineries to Superfund sites, as well as chemical and manufacturing facilities. So a whole plethora of types of projects where we've had, again, we're within a very short period of time, you're meeting cleanup criteria per the regulatory standards. So let's review what the process really is here. The Plume Shield program, REGENESIS will evaluate and provide a lump sum price. So, you know, this isn't for every site, but on the vast majority of the sites where there's a reasonably well-defined PFAS plume, you know, assessed by a competent engineering firm, we will be able to take this on under the Plume Shield program, where we'll evaluate the data and we will provide a lump sum price. Once that lump sum price is accepted, we will perform all of the installation and commissioning. And only when the performance criteria are met in the key monitoring wells is any money exchange hands. So we are so sure of this technology and confident in our ability to execute it that we're willing to move forward on our own nickel. And with it comes a standard 10-year warranty. Now, longevity of plume stop to treat PFAS is estimated on the orders of decades. If we put in a really robust injection, we feel confident in most sites stopping plume stop and tying it up for decades and decades. We are going to offer a standard 10-year warranty as part of the program, and that's because we're not going to have a site not perform. If the site isn't performing to our standard, we want to be able to come in and fix it. So that's just part of the process, part of the program. If a particular customer or a responsible party or site owner wants a longer warranty, a 30-year warranty, we're very happy to do that. In our informal polling of industry, that hasn't been called for. You know, we'll have to do a more robust injection up front, and it'll cost more for that 30-year warranty. And generally, industry, you know, the customers are saying, hey, listen, a 10-year warranty is fine. You know, if in year 17 we start to see PFAS show up, we'll just come in and do it again. So that's an overview of the process. But let's get a little more detail here. The lump sum price that we'll implement this for includes filling any data gaps. We often come in with our flux trace technology, which is a passive flux sampler that we put down wells to find exactly the vertical zone where the contamination is moving. We'll then come in and do a full design. We'll perform all of the installation work, working right alongside the consultant and the environmental engineering firm involved. We'll supply all the product. We'll perform the field work. And then we'll do what we call commissioning. And what that is we'll come back and study the performance wells and make sure that they're reaching the goals that we need to. And if not, we'll come back and adjust the injections. And we call that the commissioning. And once those criteria are met in those key wells, we'll get payment and issue the warranty certificate. So that's what it looks like. And you know, the real benefits of this, again, I'm going back to what the market was calling for, what the end users, we call them end users, but these are the people with the issues, the responsible parties and site owners. This is a proven technology with significant cost savings compared to alternative technologies. There's no financial risk to the client, because we're taking on that financial risk, and only when it performs is there money exchange hands. There's no waste generated. There's no waste going off to landfills or incinerators. You're not pumping and treating and having to handle the filtrate that's generated. There's no operation and maintenance. There's a warranty that comes with it. and it's sustainable. There's no active pumping, there's no waste incineration, etc. So very, very, very low carbon footprint on this. So we have several other things that we're working on. We actually have several models that we've developed that'll help engineering firms, and consulting firms explain to their clients how this will work and what we can expect of having a plume shield in, and the time involved before we will meet criteria for cleanup. If there's any questions about performance against pump and treat, we actually have an engineering firm that's really a pump and treat expert firm that's putting together a calculator to calculate the actual cost of implementing pump and treat systems for PFAS. And that'll be available. We'll have that available to people to review and compare to a plume shield cost and the effort for putting in plume shield, so that there's an apples to apples comparison. And that'll be completely transparent. It'll show all the assumptions and the criteria, and we can. I think it'll be a tool for engineering firms to really help them evaluate the cost and benefits of different technologies and the benefit of plume shield. So with that, there's also third-party references on PFAS treatment with the Plume Stop technology and what we're now calling the Plume Shield type of an approach. These QR codes, you can just shoot these with your phone now and download the information. The one on the far right, the Remediation Journal, is actually a third-party analysis of longevity of this approach using the colloidal activated carbon in situ, and what can be expected in terms of longevity. And I can tell you that it's decades and decades of longevity with a single injection. And that's if the source is not removed and there's a continuing influx of contaminants. However, if the source is treated, as John was showing, covering, capping or putting membranes over sources or removing the sources, those plumes will have a declining input to the plume shield barrier. And in those cases, we think one injection of plume shield may last forever. If there's a declining source, that plume shield will probably absorb the contaminants, and you will have very, very little ever migrating out of that zone. And if it does migrate out over decades, it'll be below regulatory standards in some cases, so you won't have to do another injection. So there you have it. There's a little rundown on where we are with treating PFAS in situ and the plume shield offering, and it is definitely evolving. This approach with guaranteeing and injecting under a contract like that is evolving, but we're certain to keep you abreast of how it's evolving. And with that, I'll say thank you and turn it back over to Dane.
All right, thank you, Scott. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple of quick reminders. First, you will receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions. This is a question for John. John, the question is, how do you prioritize minimization efforts?
That's a great question, and one that's a little hard to answer sometimes. But again, I think when you're looking at treating an effluent, we're looking to meet a standard at an outfall point, and the goal is to identify where the largest concentration of sources is coming from. And in that case study that I did for Selfridge, that was a good example where we did identify where the locations of the highest contribution were, and to address those. And so I've worked at whether it be a chemical manufacturing plant or a terminal or whatever, we may find areas where, let's just say, for example, an AFFF was applied. And if we go to the ones where, so sampling at those locations and within the effluent piping network towards the wastewater plant or towards the outfall, as we sample through there at varying points, we can understand the level of contribution. And so as we start putting minimization efforts, if we go for the ones that we believe and have data that suggests that they're the largest contributor, as we do that, maybe it'd be a phased approach, and maybe only one or two areas will need to be minimized in order to meet that objective at the end. Maybe more will, but at least it helps us to identify where the largest contributing is. So that becomes the diamond is in that assessment to really determine where those sources are.
All right, thank you, John. So here's another question. This one is for Scott. And Scott, the question is, how many Plume Shield guaranteed projects have you accomplished?
Yeah, to date, we're involved right now in 2 that we're now working on the contract with and we're involved with, but we think that this is probably going to have legs, doing this sort of lump sum guaranteed. So I would expect it to be growing rapidly in the coming quarter.
All right, thank you, Scott. So we have another question here. This one is for John. John, the question is, how does sedimentation affect treatment in stormwater?
Yeah, that's a very great question, and that's something we're learning as we're going. But we are having to look at, when we're looking at minimization efforts and/or treatment of the stormwater, we're having to evaluate both a dissolved and a total phase to really understand, because what happens is sometimes in a passive treatment scenario for stormwater, we don't have the ability to completely eliminate suspended solids. Typically you get stormwater during rain events and they become quite turbid events. And so we may need to find ways to, through that process, to try to settle out more of those solids, because as we know, especially with compounds like PFAS, they're going to have a higher propensity to attach themselves to these very small particles of soil or whatever it is in that suspended material. So that is something that needs to be done, that could be done through different levels of filtration as well.
All right, thanks, John. So we have another question here. This one is for Scott. And the question is, why only a 10-year warranty offering?
Well, as I alluded to, we have the ability to offer a 30-year warranty, or even longer if people want it. It's just that we're going to have to inject a lot more carbon initially to warrant that for that period of time. And in many cases, you probably don't need that much carbon, but we would have to, in order just to cover our risk, over design this and inject it. So it would be an expense thing. There may be people that feel that they really want that warranty for 30 years and would be willing to take on that expense. But most people that I've talked to so far, anyway, have said, listen, if it works for 15 years and we need to re-inject it, then we will. But that's how we came to the 10-year. But again, we can move off that if people need to.
All right, thank you, Scott. That is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about services from AECOM, you can visit aecom.com. If you'd like to learn more about remediation solutions from REGENESIS, please visit regenesis.com. Thanks again very much to John Cuthbertson and Scott Wilson, and thanks to everyone who could join us. Have a great day.